All right, so here we have an interesting statistics problem. So it's asking us to generate a list of 150 integers between 25 and 75 and calculate the standard deviation of the list. So if you don't know what standard deviation is, it's kind of a measure of how spread out a data set is. Okay, and then it asks the user for determine if a number is exceptional or not for that particular data set. So this has to do with something called a normal distribution. So in a normally distributed data set, so something like a class of students, if and let's say we're talking about grades, if you look at all the students' grades and calculate the standard deviation from the class, right, you would expect in a normal distributed data set that like 66% of the data would be within one standard deviation of the average. Okay, so most of the data is kind of centered around the mean or the average value in the class, and that kind of makes sense, right? So if it's kind of outside of that range, you would consider that maybe an anomaly or something like that. So something went wrong with that particular piece of data. So that's what this program is kind of aiming to do, is we're checking to see whether numbers are exceptional or within one standard deviation of the mean. Okay, so it goes on and it tells us how to actually calculate the standard deviation. Python has a built-in function for this, but let's just practice our lists and loops, and we can do it by manually here. Okay, so we have the data in the list, and first thing we do is we find the average of all the numbers, and then we calculate the error between each point and the average. Okay, and we square it because we don't want it to be negative, first of all, because then the errors will cancel out. It's called a mean squared error calculation. And then since we squared it, so then we add it all up and find the average of that. And then since we squared it, we need to take the square root back at the end in order for it to normalize itself. Okay, so that's how we're going to calculate the standard deviation, and then we can check whether any other number entered from the keyboard is considered exceptional or not. So it's kind of long, but it is not overly complicated, I don't think, to get the solution. We just need to follow kind of the instructions that it gave. So we're going to need some random numbers, and we're going to need to do some square roots, so we need the math and random libraries. Okay, so the first thing we need to do is generate the list. Okay, so we'll start with a blank list, and we will go from 0 to, I said 150 numbers. So we will append a random number to the list between, what did I say, 25 and 75. Okay, so we generate the random number. I'm just doing it inside the append here and append it to the blank list. So we can check that right now, I guess. Okay, so there's our 150 random numbers in a list. Okay, now I need to calculate the average of the list. It said using no statistical functions that are built in, so we'll just do everything by hand. So to calculate the average, I need the total. So I add up all the values in the list and divide by 150. So for I in range from 0 to the length of my list, and I add up all the values. Okay, and then so I said to call the average U. So U is equal to total divided by 150. So let's print that out, make sure, oops, always forget the column. What am I doing here? Let's see if I can find it. Maybe I'll stop printing X here for a second. What am I doing wrong? So I'm printing x twice, should be printing out mu. Okay, so there's the average, 50. That should make a lot of sense because I'm generating random numbers between 25 and 75, so I should keep getting averages around 50 every time I run this particular program. If I was maybe reading different random values each time, then I would start getting different values for that, but that does make sense. Okay, now I have to do the mean squared error. So that is, so I said to generate a new list, so an error list, okay, equal to the difference between the original list and the average squared. So I need to go through each value in my original list, so the 150 values, and for each one I'm going to append the difference between my x value and my average, and I'm going to square it. Okay. So after this, I will get a list of all the different error values squared. Okay. So it would take like 60 and subtract 50.2 and then square it, and 44 minus 50.2 and then square it, and that would be the second value in the error list, etc. Okay. Now I need to find the average of the error list. So I do the same thing I did here, except I'm doing it with not the X list, but the error list. I suppose I could just put 150 every time, but there we go. Okay, so what have I got here? So there's my list, there's my average, this is my the average of my error list. Now I can calculate the standard deviation as just the square root of that value. Okay, so standard deviation is math.square root of v. Okay, so I don't need to print this anymore. I don't need to print this anymore. I should print out my standard deviation. Okay. So 14, 15, so it's usually what it would be. Okay. If this was a, so what you would expect, I guess, is, okay, well, if the mean is around 50 and the standard deviation is around 14 to 15, you would expect most numbers to be anywhere between like 65 to 35, and anything outside that range would be an exceptional number. So the last part of the program is it's asking you to do the to figure out whether any number is considered exceptional. Let's finish this comment here. Okay. So we need to check if a number is exceptional. So we got to get that number from the keyboard. Okay, and so what I guess I can do is I can, there's like a high and a low range, right? So you have your high range, it's there, you have your low range would be the average minus the standard deviation. And I just have to check if my num is bigger than or equal to low and my num is less than or equal to high. Okay. So that means it's outside my range, or sorry, it's inside my range, which means it's not exceptional. And otherwise, it is exceptional. Okay. What did I do? At the bracket. Okay. So if I'm entering a number, so again, we're roughly thinking 35 and 65 here. So if I enter 75, that number should be exceptional. Okay? If I enter 55, that number is not going to be exceptional. Okay, so there's a little kind of normal distribution statistical program that you might end up doing in a data management class or something like that.